Hello, 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 hello. Okay, I'm audible now. I'm not audible. Okay, okay, I'm starting the class. Okay, first of all of you have joined. 18 have joined, 17 have joined till now. Okay, please tell me about your, about any problem up to the last class. Please, today I'm taking this class as discussion class, and after that I'll start the lesson. Please discuss about any problem you have faced in the lesson up to the last class. Yes, please, now you are free to speak. Please tell me your problem, any problem you are facing up to the last class. Obviously, there must be some problem. It is not possible that all the things are clear and all the things you have got satisfactorily, but please tell me, or I will ask some questions. From that, your class evaluation will be given. Please tell me any problem you have faced up to the last class, or any query or any confusion about the lesson. Yes, yes, any problem, any query, any confusion, or any problem you are facing during the class, please, please reply. You are free to speak. Yes, Hey, I'm talking to you. Please open your audio and video and please reply. Please speak out. Yes, my voice is not coming properly. Okay, don't worry about my voice. Please tell me about your problems, about your confusion, about the lessons or class. All the lessons I've discussed up to the last class, all of those are clear. Yes, yes, please speak anyone one by one. Please talk. I'm here to discuss about all the problems up to the last class, about the lessons, about the topics up to the last class. In the last class, we have started your main syllabus of soil mechanics 2, and before that, we have discussed about the strength of soil from your previous semester. Please tell me what were the problem or what is the problem you have faced or any confusion, any query, any understanding problem, any problem in the notes. Please speak out, anyone. Hello. Okay, okay. First, there is one named Monojit Mehta, roll number 11, I think. Yes, yes. Acha, please tell me your personal problem about the lessons or anything you didn't understand in the last class or the previous classes. Please tell me. Actually, in the previous classes, I have discussed about the lessons. You didn't reply anything or you didn't ask for repeating or something. But there must be problems, no? This is not the classroom teaching. This is only online teaching, and you must have some problems. It's not possible that you all have got all the things very clearly, or you have understood all the topics and all those things very clearly. There must be some problem. Monojit, where are you? Your name is in the first of the list. Yes? Okay. If some network issue is there regarding the audio, then please you may write in the chat box. Yes, please write down about any problem, any personal issues about the lessons and the class in the chat box. If there is a no problem, no, it's not possible. I have taken, I think, 3 or 4 classes. There must be some problems. because first three classes I have taken on shear strength of soil and one class I have taken on earth pressure. Okay, anyone else? Okay, Kollan research, I think roll number 9. Please tell me the problem or any issue you have faced regarding the classes, regarding your lessons of shear strength of soil or earth pressure theory I have taken in the last class. Hmm. Weight of backfill. Where is that point? Weight of backfill. Okay, you need weight. Okay, backfill means I think you have understood the term backfill. Okay, I can show the previous notes. In the previous notes, you have I think you have uh, got this figure of some retaining structure. This and the arc pressure, lateral arc pressure is working on the vertical backside of the retaining structure. No, that means this, this there is soil, there is this part, this part, and this part is continuing to some length, and this part is empty. Okay, this part there is soil, in this part there is soil filled up to this, and this part is empty. That means some lateral pressure or lateral force is coming to this retaining structure, and due to that the structure is tends to move like this, like a vertical plane. This wall or this structure tends to rotate or move. Now as this soil, this part of backside of the retaining structure is filled up with soil, obviously this soil have some weight. As there is some object, the weight of this object you have to consider, and this part of soil have some weight of some W. W means obviously weight equals to m multiplied by g, mass multiplied by acceleration due to gravity. And as this height is not specified or not constant for different heights of this retaining structure, that's why this part of soil, the weight of this part of soil, we have to take in terms of unit weight. Unit weight means obviously the weight of, yes. Okay, I'll give you the lecture video link. Okay, if there is some problem in audio, please watch that. I will send the link of Google Drive and YouTube also. I'll upload the video in the YouTube and upload the link in the Google Drive. You may download the link or you may simply watch the video. I think in that video there will no such audio issue. Okay. Uh, now, okay, na? Okay. Now, as height, this height is not specified or not constant for different retaining structure. This height may be 10 meter, maybe 7 meter, or maybe something like that. But this weight of soil you have to represent in terms of unit weight. Unit weight means weight per unit volume. That means W divided by V. Okay, W divided by V means weight is M multiplied by G. That is, if you want to calculate that unit weight, that is Unit weight is nothing but, I think, acha, you can see the presentation, no? Okay, okay. Okay, then I can write down. Okay, okay. Unit weight is weight, yes, yes. Anyone want to say something? Okay, weight, sorry, weight per unit volume. Okay, that means W divided by V, and this W is equals to N multiplied by G divided by V, and equals to M is nothing but rho multiplied by V. That means density multiplied by volume. That is V multiplied by rho. And there is a term of G divided by V. And from that you can get that unit weight equals to rho multiplied by G. Okay, this is the weight of soil, weight of backfill soil, and in terms of unit weight means obviously this volume of this part of soil, the part of soil behind the retaining structure, this part of soil have no constant weight. When these retaining structure, the dimension of this retaining structure is changed, obviously the volume of the soil is changed, and obviously on that way the volume of the soil, volume of this part of soil will change. That's why you cannot take the weight of soil as a constant parameter. That's why you have to take this parameter that is constant. Obviously that is constant. This rho multiplied by G is equals to unit weight, and that unit weight is represented as gamma. Okay, this unit weight is represented as gamma, and rho is the density of soil, and G is the acceleration due to gravity. You will be given this value rho and G. You know the value of G. By that you have to calculate the unit weight of that soil. This is the representation of weight of backfill soil. Okay, as because the dimension of this retaining structure is not constant, that's why we cannot take this weight of soil as constant. As the dimension of the structure changes, then obviously the volume and the mass of this part of soil will change. That's why you have to take the weight of backfill soil in terms of unit weight, that is gamma, and you can calculate that gamma equals to rho multiplied by G. Okay, is that okay, Kalyan? Okay. And I think you all have some issue of audio, no? All of you are facing this problem, this audio problem. Maybe this is due to network issue, but maybe from my side or from your side also. All you are in your home, na? Weather is obviously weather is not good here also. That's why maybe the audio problem is there or network issue is there. But I think you all are using the mobile net hotspot, mobile hotspot. That's why maybe the network issue is there. Uh, okay, I think that is not a big deal because I send all the video lecture link and you may watch that in the YouTube from the YouTube link or in the Google Drive also. I will send the Google Drive link also. You can download the Google Drive from Google Drive. Okay, you may download that video. Okay, okay. I think the weight of the backfill soil is clear now. So, is there any other problem? Please say Swati. Swati, are you there? Swati, are you there? Okay, please tell me about any problem you have in regarding the lessons in the previous classes. Okay, all you have got clearly all the topics, all the points. Okay, okay. Anyone else? Okay, there is one name that is Onik. Onik, your roll number is not there. Are you there, Onik? Onik Maharatna. Onik Maharatna, are you there? Onik Maharatna, are you there? No, 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 no. I'll take the attendance from the Google quiz. I'll send the Google quiz after the class. No need to mention your roll number and name. Onik, are you there? You are not there? Okay, okay, you are there. Okay. Onik, you have any problem regarding the lessons from the previous classes? No, sir. Directly, no, sir. Why? There must be some problem. Okay. And another thing, I have taken, I think, 3 or 4 classes is the way. Okay, that is one issue most of you are talking about the audio problem, and that is not that is due to the network issue. I think from my side, maybe from your side also, uh, and that I cannot do anything because the weather is not good here. But okay, that is one issue, and obviously I cannot do anything about that. I will send the. I can do one thing that I will send the lecture video. You can watch that. I think there the audio issue is not there, and obviously if there the sound is low in the video, you can watch that by connecting your headphones. Okay, because maybe this recording is by screen recorder. Okay, and in that case audio may be low. Then you have to use your headphones to watch or to hear the audio from the video link. Okay, okay, okay. And any suggestion about the teaching way I have used? Anything from your side? Is this okay? Is the way I took up to the previous class, is that okay? Or anything you may suggest? Sunny, Sunny Kunai, you have joined now. You have joined now. Oh, okay. Okay. Any problem about up to the last class? Are you sure? Nah, sir. Why? Okay. Okay. Please be updated because I did not discuss more. I just discuss about a small things, small 2 or 3 topics regarding your syllabus. Please be updated up to the previous classes. When I'll take the class in the from the next class, please update it up to the previous classes. Okay, and forget about the lesson. The way I have taken up to the last class, is that okay or not? Please suggest any modification. Any modification I should take or something. Okay, okay. Anyone can suggest if there is some problem or you want to suggest some modification in the notes or the way I am sending the notes or the video link or the Google quiz you may suggest. Yes, no suggestions. Ex- Extra say means okay. Extra say means you want to solve some numerical problems, no? Okay, okay. That's
Okay,
good.
but first you'll have to unlock your device.
That is one good suggestion. I will obviously send some numerical problems. Obviously, there are lots of problems regarding your the first chapter or first module. That is module number 3. I have started in the previous class. There are so many numerical problems. I will send, and you may solve it yourself or may take my help or from books and the notes I will send. You may you may take the help from all those things, and obviously you may take help from me also. And okay, that is a good suggestion. And anyone else, any modification you want regarding the way of class I take up to the last class? Okay, there is, yes, someone want to say something. Is that Sanjeev? Yes. Active and passive condition, I haven't discussed yet in the last class. That is, in this class, I'll start from the artificial rest condition and other 2 conditions, that is active condition and passive condition. I didn't discuss in the those things in the last class. That is pending, obviously, and that is the different thing that I will discuss in this class or in the next classes. Mm, But up to the last class, that is, I have discussed the arc pressure and the basic concept of arc pressure, how arc pressure is coming on the returning structure from the lateral side or from the horizontal direction. That I have discussed in the last class, the basic concept of arc pressure, lateral arc pressure. These 3 types of three conditions, that is active condition, active condition and passive conditions, I did not discuss yet in the last class or in this class also. I'll discuss in the next class, or if I got time in this class, I'll discuss. Okay, and anything else, Sanjeev? Okay, Okay, anyone else want to say something? And obviously, like Swati, you may suggest some modification or some extra things you want. Shubham Sharma, I think roll number 56. Shubham Sharma, are you there? Yes. Any suggestion or any query, any question from your side? Directly, no, sir. Why? Okay. Okay. Now, Shobhan, roll number 58. Are you there? Shobhan, are you there? Hey, Shobhan, you are not there. Okay. Shobhan, yes. Any problem, Shobhan, regarding your network? You have left and joined again. Okay. Okay. My question was that any suggestion or any question from your side? Directly, no, sir. This is not the way of online class. Please tell something, no? Network issue. Okay. Okay, you may write down in the chat box also. Anindo, Anindo Ghosh, your network is not good, I think, today. If you have any problem, you can write down in the chat box. I will see. I know. Weather is not good. Okay, okay. If you have some suggestion, you may mail me or you may message me. I think some of you have my personal number also, contact number. You may message or mail me. Uh, I will try to resolve all your problems. Okay. Okay. Now there is not more time left. Today I'm starting the lesson. Uh, Today I'll start and I'll discuss only on the pressure at rest condition because there is not more time left. And someone have asked that what is about active condition and what is about passive condition. Sanjeev Kumar, I think. So please give your WhatsApp number. Is there any problem? We will contact you. Okay. Obviously, this is my WhatsApp number. I have written in the chat box. If you need, you can take that and you may WhatsApp. I will try to resolve your problems. Okay. Okay, just I'll discuss only one topic. Today I will discuss only one topic, that is arc pressure at rest condition. This is There is some a little bit of numerical things in this part, that is arc pressure at rest condition. Arc pressure at rest condition means when when I am giving the same figure here also, when the returning structure is in equilibrium condition or in the rest condition. At rest condition means when there is no movement, there is no movement of the returning structure or in the soil in this side, in this lateral side or from horizontal direction. Then the arc pressure is called, then that kind of arc pressure is called the arc pressure at rest condition. When this retaining structure or this part of soil at the back side of the retaining structure is in equilibrium condition or at rest condition, then that arc pressure is called the arc pressure at rest condition. And there is one numerical equation for this arc pressure rest condition. Arc pressure at rest condition is represented by this notation P naught or P, this is 0, P is 0 in the suffix, and the equation is K naught gamma H or K0 gamma H. Gamma is unit weight, you all know, now you have the clear idea about gamma or unit weight, and H is the height of the retaining structure. Now about K naught or K0, this is the coefficient of arc pressure at rest condition. Now in the previous class I have discussed about the pressure at any point of water, underwater condition. If you want to calculate the pressure, then you have to use the equation that pressure equals to rho gamma h. Rho gamma h, that means density of water, g is the acceleration due to gravity, and h is the depth of the point below the surface of water or maybe any liquid. Now rho into g is gamma. Here is also the same thing, rho into g and h. This is the rho g h. This is the pressure, equation of pressure at any point underwater or under some liquid. That is rho gamma h. This part is rho gamma h. Rho into, sorry, rho gh. Rho gh, and obviously gamma is equals to rho and rho multiplied by g. That means gamma H is nothing but the pressure at any point under water or under any liquid. Now as this soil thing, this substance soil is not exactly equivalent to the water or some other liquid, but there is some part of liquid and some part of solid and some part of gas. You have studied in your previous semester that there are three phases or three things, three substances, that is solid part, liquid part, that is water, and gaseous part, that is air. That's why this same equation with some modification, that is with a multiplication of some coefficient, you can use this as a equation of arc pressure at rest condition when this soil is in equilibrium condition. Now if you want to derive that, then you have to understand this figure. If you take some elementary part of soil, this type of elementary part of soil, where this sigma 1 represents this pressure. Sigma is stress, you know that sigma represents stress, and this arc pressure, lateral arc pressure, is represented by this sigma 1, and this is also the lateral pressure, but not in this direction, not in direction of x-axis, but z-axis. Sigma 3 is lateral arc pressure, but in the direction of z, in horizontal direction also, but in the direction of z or perpendicular to the x-axis. And sigma 2 is not lateral earth pressure. This is coming from the vertical direction, or this is acting vertically. This is not lateral earth pressure, but vertical pressure, or vertical pressure means here the weight of this soil. Weight means W into W equals to M into G. This sigma 2 is vertical pressure, or the unit weight of soil. Okay, and these two, sigma 1 and sigma 3, is nothing but the lateral pressure in perpendicular directions. Now, to derive this equation for K naught or K0, coefficient of earth pressure, you have to take help of strength of materials. That is the definition of mu. Mu is Poisson's ratio. Mu is nothing but lateral stress divided by longitudinal stress. What is the definition of mu? That is lateral stress divided by longitudinal stress, or maybe you may write down that that is dl by l, sorry, dl by l whole divided by dv by d. That is dl by l means this is the lateral strain, and dv by b means this is longitudinal strain, or maybe this is longitudinal strain, this is lateral strain. L is one dimension, that is maybe this dimension, and B is this dimension. Okay, that is uh, strain, lateral strain divided by longitudinal strain. Now, I have told that mu is equals to lateral stress by longitudinal stress. Now, you know that the relationship between stress and strain, that is stress by strain equals to the Young's modulus, or modulus of elasticity, or those kinds of modulus, that is Y or E. Now, you may multiply E in both the, that is numerator and denominator, that is with lateral strain and longitudinal strain, and by multiplying E or Young modulus or modulus elasticity will get stress, that is lateral strain multiplied by E. E is modulus of elasticity and longitudinal strain multiplied by E. Okay, now that will be equals to lateral stress divided by longitudinal stress. Okay, and here lateral stress is sigma 1 and longitudinal stress is sigma 3. Okay, that is the definition of Poisson's ratio. And if you want to that is sigma 1 divided by sigma 3. Sigma 1 divided by sigma 3. So maybe this is much large. Okay. Now from that sigma 1 divided by mu equals to sigma 3. From this you may sigma 1 equals to sigma 3 by mu. And obviously, sorry, not sigma 3 by mu, that is sigma 3 equals to sigma 1 by mu. Sigma 3 equals to sigma 1 by mu, and by the same way you may derive the relationship that sigma 2 is also sigma 1 by mu, and by that you may derive the equation for K naught or coefficient of heart pressure at rest. That is, if if the soil at the backside of the retaining structure and this retaining structure is in equilibrium condition, then obviously the effect of all these stresses sigma 1, sigma 2 and sigma 3, the effect of all these stresses are in equilibrium, or that sigma 1 minus mu sigma 2. This is the effect of sigma 2 on sigma 1. That is mu, sorry, minus 2 minus mu sigma 3, that is the effect of sigma 3 on sigma 1. Mu sigma 3 will be equals to 0, and from this figure, as this is sigma 1 is longitudinal stress, or longitudinal, and this is lateral stress, that means both sigma 1 and sigma 3 are lateral stress, or maybe you may represent this as lateral arc pressure. That means sigma 1 and sigma 3 are equal. Sigma 1 and sigma 3 are equal, as from this figure sigma 1 and sigma 3 is acting horizontally or in lateral direction, and as those sigma 1 and sigma 3 may represent as lateral pressure, those sigma 1 and sigma 3 are equal. That means from this equation you may write down this one, that is sigma 1 and sigma 3 is equal, and from that you may derive sigma 1 is equals to mu divided by 1 minus mu sigma 2, that is this this gamma h is nothing but the sigma 2, and p0 is nothing but sigma 1, and k naught is this one. Is this clear? From this you may derive sigma 1 equals to mu divided by 1 minus mu multiplied by sigma 2, and sigma 1 is P naught, or arc pressure at rest, and sigma 2, this is sigma 2 is coming from vertical direction, and that is the weight, and weight is nothing but unit weight into height, that is the weight per unit area, that is pressure or stress. Weight per unit area is, that is pressure or stress, and that is that stress, that vertical stress is sigma 2, that is gamma h. Sigma 2 is gamma h, and sigma 1 is p naught, and this is k naught, or coefficient of arc pressure at rest. Okay, okay, up to this I can stop the today's class. Is there any problem up to now? Okay, okay. Please, I will send the note and the video lecture. Watch that and study the note. In the next class, we'll discuss about these things we have discussed in this class. Okay, okay. Thank you all. I'll send the that Google quiz also. Please submit that. I'll take the attendance from that. Okay. Okay. Thank you. I'm stopping the presentation. Okay. You may leave the session now.